High Point Chemistry. This is part 2 of your lesson on finding the right conversion factor. So if you want to solve problems, we need to determine by reading the problem what conversion factor to use. So we're actually going to begin. That's going to be your assignment. It won't be to solve the problem. It will be to write out the problem with the correct conversion factor. Then once I check it next week, you'll start solving the problems. So the first example we're going to use is right out of the book. On page 236, section 9A, it's number 6. It reads, it says, how many moles of atoms are in 1 pound of lead? All right, so there it's not asking for a quantity as in the quantity of atoms. It's asking just for the amount of moles, like how many dozen, how many moles. It's kind of the same thing there. How many moles are in a certain mass? So it's asking for moles and it's giving you mass. So that is a clue to tell you if you have mass and moles that you're going to use the periodic table. So before we do that, we need to set up the problem. We need to write down the number that it's giving us. It's giving us 454. So we write down 454, and then we need to know, is it saying grams, moles, molecules, something in the quantity factor? So in this case, it's saying grams. Yeah, 454 grams. The next thing we have to write is what substance is it talking about? It's talking about lead. So we're going to put the symbol for lead. So we have 454 grams of lead. And we can put a line under that to begin our conversion. All right. So we determined that we're going to use the periodic table. So let's find lead on the periodic table. Let's see if I can pull this up closer to the camera this time. Lead is like peanut butter. It's PB. Okay, right there is lead, if you can see it. The molar mass is 207.19. Okay, so I'm just going to write for review. You don't have to do this every time. For review, what this means. 207.19 grams of lead are in or are equal to 1 mole, okay, that huge number of lead atoms. Sorry, I meant to write PB. Moles of lead atoms. All right, and we could just say moles of lead. So we want to use this. This is our conversion, okay, quantity that's equal to each other. We want to change this to a factor. We want to use multiplication. So we want the grams to cancel out. So 207.19 grams of lead, I don't know why I wrote pounds there, lead, is equivalent to 1 mole of lead. All right, so that's our conversion factor. Is this going to cancel out? Or is everything going to cancel out? In other words, is the quantity going to cancel out? The grams is going to cancel out, and so is the substance. Okay, in this case, it's lead. So in this case, what we would be doing is taking this number and dividing it, but that is not what we're worried about for this assignment. We just want to determine the correct conversion factor and set it up correctly. All right, so let's go to another example. On page 248, in your chapter review, find number 10, and we're going to just do number 10A. Number 10A, it says, how many atoms are in the following 12.01 grams of carbon? Okay, so it's giving you mass, but it's asking for atoms, okay? So if you ask yourself the 3 questions I gave you, you are going to need 2 conversion factors, all right? Because there's nothing listing moles. It doesn't say moles to atoms, it doesn't say moles to moles, and it doesn't say moles to mass. But if you remember from your homework, you saw that the mole is what's considered the bridge, all right? So we need to take what is given, all right? I'm going to write 10A here. 10A. We're going to take the number that's given in 10A, 12.02. Okay? The quantity is grams, and the substance is carbon. We're going to write all that down. All right. We're going to do a conversion. All right. We need to convert 2 moles, and it's going from mass to moles. Well, how would I find mass to moles? I need the periodic table. Okay. So I need to find carbon, if that's close enough, I'm not sure. 12.01 grams. I'll write it down at the bottom. 01 grams is equal to 1 mole of carbon. All right. So that's my little conversion factor. Again, you don't need to write that down, but in your head you want to be thinking, where does grams of carbon go? We want to put that at the bottom. Grams of carbon, and there's 12.01 grams of carbon in 1 mole. All right. Now, we need another setup, okay? It's asking us for the number of atoms. And you already know how to convert moles to atoms. You know that 1 mole of anything equals 6.02 times 10 to the 23rd of anything. So we're going to write that. We want the moles to cancel out, but first we need to say, what is our substance? 12.01 grams of carbon is equal to 1 mole of carbon, not 1 mole of anything else. Nothing else has that specific mass. So let's make sure we put the substance there, all right? Then I'm going to do the same thing here. 1 mole, and since I'm talking about carbon, I'm going to put carbon there, and 6.02 times 10 to the 23rd atoms of carbon. All right, and then we're just going to check to see if our setup is good. First thing I can cancel out are the 2 grams, top and bottom, and the 2 carbon, top and bottom. Second thing I can cancel out is the mole type of quantity, top and bottom, and the carbon substance. All right, so that's our setup for 10A. It is also the setup for 10B and C. All right, so we had to ask ourselves, how can I get from grams to atoms? I needed to first go from grams to moles, periodic table, from moles to quantity of atoms, Avogadro's number. All right, the next example is 11A. I think I'm going to erase this here and start over and write just a little bit bigger for you. All right, 11A. 11A says, how many moles of iron are in 37 grams of iron? Well, it's asking me to go from moles to mass to moles, or moles to mass. So I will need to use my periodic table. I'll need to look at the periodic table. I'll need to find iron. Okay, iron, it says, is 55.8. I think that's an 8.85 grams in a mole. All right, so let's start with what the problem states. It says 37.0 grams. All right, grams is the quantity, iron is the substance. All right, the setup needs to be grams of iron converting to moles of iron. All right, and where are we going to get the numbers for grams of iron to moles of iron? From the periodic table. We just checked the quantity. It was 55.85. Okay, and we know that the mass of 1 mole from the periodic table of iron is 55.85. So this is a true statement about iron, about the mass of a mole of iron, and it will cancel out. Grams and grams cancel out. The substance, iron and iron, cancel out. So we know we have a good setup. 11B. 11B says, how many moles of krypton are in 4.58 times 10 to the 20 atoms of krypton? Well, it's asking atoms to moles. It's asking for a quantity of just the tiny little atoms. So that's our clue that we need Avogadro's number. So start with writing down what it gives us, 4.58 times 10 to the 20. All right, we want to write our type of quantity, atoms. All right, and it's atoms of, just checking here, krypton. All right, let's draw our railroad tracks there. All right, so we want to go from atoms, and it's asking us how many moles. So we can get straight from atoms to moles with Avogadro's number. So I'm going to write here atoms on the bottom, atoms of krypton, because I want atoms of krypton to cancel out. And I'm going to put mole because I'm going 2 moles of krypton. All right, let's fill in the numbers. 6.02 times 10 to the 23rd goes with the word atoms because that's how many atoms are in 1 mole. Did we set it up correctly? Well, atoms is on both the top and the bottom, so it will cancel out. Krypton is also in the numerator and the denominator, so that cancels out, and this will help us determine the moles of krypton. 11C. Okay, 11C says, how many moles of sodium iodate are in 3.25 times 10 to the 26th formula units of sodium iodate? All right, so we are going from formula units to moles. Okay, formula units are just like a quantity. They're just like molecules or atoms. So we are going to again use Avogadro's number. So I'm going to write down what it gives us. 3.25 times 10 to the 26 formula units of, what is it again? A strange one, sodium iodate. All right, so yes, that's a big thing to write there. This many formula units of sodium iodate. So we draw our railroad tracks. All right, and we're going to use Avogadro's number. So let's write the quantity that we want to cancel out. We want formula units to cancel out. So that's our quantity. Sodium iodate is our substance. We want to include both the quantity and the substance. And they were converting 2 moles of sodium iodate. All right. So again, where do the numbers go? Well, 1 mole of anything, in this case, this is our substance that we wrote down. Always be sure to write the substance down. 6.02 times 10 to the 23rd. Does everything cancel out? Formula units, yes, that cancels out. Sodium iodate, yes, that cancels out. So we have the correct setup, and if we wanted to, we could go ahead and solve it, but we're not going to do that just yet. We're going to practice more setup. We're going to go to 13, C, and D. All right, oops, let's erase that a little bit more. All right, 13C says, how many aluminum chloride formula units are in 6.17 mole of aluminum chloride? Okay, so it's asking for formula units, going straight to mole. Okay, very simple. Avogadro's number. So let's write that down. It is giving us 6.17 mole. All right, so we have the right quantity. It is telling us the substance is aluminum chloride. All right, draw a line for your railroad tracks. We want to go from moles to formula units. So I'm going to put mole on the bottom this time. I want mole to cancel out. I want the substance to cancel out, so I need to write that down. There's aluminum chloride. On the top, I want formula units, because it's asking for formula units, of aluminum chloride. All right, so let's put the numbers in. 1 mole of aluminum chloride is equal to 6.02 times 10 to the 23rd formula units of aluminum chloride. And again, it's a good setup because moles cancels out, and so does the substance. Letter D. Letter D asks us, how many, make sure I'm on the right one here. I feel like I'm repeating. Let's just double check here. 13, we did 11, A, B, and C. Yep, okay, it's sodium iodate again. All right, how many sodium iodate formula units are in 8.58 grams of sodium iodate? It is telling us a quantity of 8.58 grams of sodium iodate. All right. It's asking for a quantity. We cannot go straight from a quantity of formula units from mass, but we can go from mass to moles using the periodic table. And we are going to need more room. So let's move this to the left of the screen real quick. All right. 8.58 grams of sodium iodate. All right. Grams of sodium iodate to moles of sodium iodate. We need to use the periodic table. All right. Now I could go ahead and solve it. It's just going to take a little bit of time. We need to add up sodium 22.99 plus an iodine 126.9, if you can see that, and oxygen 16 times 3. So we need to add all that together and put the solution right there. So let me grab my calculator. We need to put in sodium. So right underneath, you can go ahead and write that. Iodine, 127, 126.9, and 3 oxygen is 3 times 16, 48. And by now, I'm sure you're very good at adding all these together, so I don't think this will be a problem for you. 4, 5, 9, okay, 197.89. Okay, so you want to go ahead and solve that for your problems. That will be the one math part that you'll be doing in your setup. All right, so it's asking for quantity of formula units, so we still have one more step, and it's going to look exactly like the one above it. We're going from moles, so 1 mole of sodium iodate is equivalent to 6.02 times 10 to the 23rd formula units of sodium iodate. All right, is the setup good? Grams cancels out. The substance cancels out. The mole quantity cancels out. And the substance cancels out again. All right, so my answer, once I do the math, should be in formula units of sodium iodate. And I believe, let's see here, 14 asks A and B, what is the mass of a mole of iron? So what would you use in that case? Let's just review. For number 14A, I'm not going to write it out. We'll just ask ourselves and answer the question. I think by now you probably know it. 14A, what would you go ahead and use? Well, it's saying grams to moles. You would use the periodic table. And that's it, just the periodic table for your fraction, for your conversion factor. Number 14B, it says mass to atoms, or atoms to mass. You're given atoms. So 14B, let's just ask the question, what would we use first? We're starting with atoms, right? If it's giving us 8.58 times 10 to the 28th atoms of krypton, we want to convert that to moles. So first, use Avogadro's number. Second, Avogadro's number will give you mole, so then you can go from moles to mass. How do you get from moles to mass? You guessed it. You need to use the periodic table. So second, use the periodic table. All right. I hope you found this helpful. If you have any questions, please feel free to Zoom me with any questions or concerns on your assignment for Friday.